Hello guys, today I am going to discuss with you numerical on random process part second. In part first we have covered few questions on random process. Now this part also covers random process numericals. So our first question is stationary random process xt has the following autocorrelation function rx2 equals to sigma square e raised to power minus mu tau mode, where mu and sigma square are constants. It is passed through a filter whose impulse response is h2 equals to alpha e raised to power minus alpha 2 u2. Response is here alpha is a constant and and u2 is a step function. Now we have to find power spectral density of random signal xt, and second part, find the power spectral density of the output random signal yt. Now the power spectral density of input is expressed as sx omega equals to a continuous Fourier transform rxt equals to integration from minus infinite to plus infinite rx2 e raised to power minus j omega to d2. Now as x omega equals to integration minus infinite to infinite sigma square e raised to power minus mu 2 e raised to power minus j omega to d2. Now the sigma square will come out as a common, and we have to we will break integration into two parts, minus infinity to 0 and 0 to infinity. From minus infinity to 0 it will open as e raised to power mu minus j omega to d2 plus sigma square integration from 0 to infinity e raised to power minus mu plus j omega 2, where sx omega equals to sigma square 1 by mu minus j omega plus 1 by mu plus j omega equals to 2 mu sigma square by mu square plus omega square. Now we move to second part of the question. Now the power spectral density of output is related to the power spectral density of input as sy omega equals to h omega square as x omega, and h e raised to power j omega equals to continuous Fourier transform of h2 or h e raised to power j omega equals to integration from minus infinite to infinite h2 e raised to power minus j omega to d2 equals to integration minus infinite to infinite alpha e raised to power minus alpha 2 u2 e raised to power minus j omega to d2. So alpha will come out as out of integral. So integration from 0 to infinity e raised to power minus alpha plus j omega to d2, it will lead to finally alpha by alpha plus omega. Substituting equation second in equation first, we will get sy j omega equals to alpha by alpha plus j omega square as x omega equals to alpha by alpha square plus omega square multiply x omega. So finally the power spectral density of output will be alpha by alpha square plus omega square 2 mu sigma square by mu square plus omega square equals to 2 mu alpha square sigma square by alpha square plus omega square mu square plus omega square. Now we move to next question. The next question is a deterministic signal xt equals to cos 2 pi t is passed through a differentiator as shown in figure. Which xt pass through 1 by 2 pi d by dt, which leads to finally yt. Now in first part we have to calculate determine the autocorrelation xx rxx 2 and the power spectral density as pi xf. In second part, find the output power spectral density as y by f. In third part, we have to evaluate Rxy 0 and Rxy 1 by 4. Now in first part, we know that the autocorrelation is expressed as Rxx tau equals to e raised to power e xt plus tau plus xt. So our autocorrelation equals to 1 by t integration from minus t by 2 to t by 2 cos 2 pi t plus tau cos 2 pi t dt. Rx2 equals to 1 by 2t integration from minus t by 2 to t by 2 cos 2 pi t 2t plus tau plus cos 2 pi tau dt. So autocorrelation will be 1 by 2t sin 2 pi 2t plus 2 by 4 pi raised to power t by 2 plus cos 2 pi tau t, which will be in the limit minus t by 2 to t by 2. Now simplifying, we get autocorrelation function as cos 2 pi 2 by 2. Further, we know that as xx f equals to integration from minus infinite to infinite Rxx to e raised to power minus j omega 2 d2 equals to 1 by 2 del f minus 1 plus del f plus 1. We have using cos 2 pi fct equals to 1 by 2 del f minus fc plus del f plus fc. Now for second part, ryy2 equals to dy dt rxx 2. So it will come out as pi sin 2 pi 2. Also as yf equals to h j omega s xx f. So j omega s xx f. So it will finally come out as j pi f del f minus 1 plus del f plus 1. Now for part C, again we have Rxy t equals to e xt by t plus 2. Rxy t equals to 2 pi t integration from minus t by 2 to t by 2 sin 2 pi 2t plus tau plus sin 2 pi tau d2. So Rxy2 equals to pi by t cos 2 pi 2t plus tau by 4 pi minus t by 2 to t by 2 plus sin pi tau t. It will equals to pi sin 2 pi tau. Then Rxy of 0 equals to 0. Rxy 1 by 4 equals to pi sin pi by 2 equals to pi. Now we move to our third question. And last, if probability distribution function of Rayleigh distribution is given by expression FR equals to R by sigma square e raised to power minus R square by 2 sigma square, then above that the cumulative distribution function CDF of Rayleigh distribution will be FRR equals to PR less than equals to R equals to 1 minus e raised to power minus R square by 2 sigma square UR. We know that the CDF may be obtained from PDF. So the formula of the CDF is fxx equals to integration from minus infinity to x fxx dx, where frr equals to integration from minus infinite to x frr dr. Now since r never becomes negative, therefore integration limits will be from 0 to r. Thus frr equals to integration from 0 to r sigma square e raised to power minus r square by 2 sigma square dr. Putting r square by 2 sigma square equals to t, so that 2r by 2 sigma square dr equals to dt, or r dr by sigma square dt. And when r equals to 0 and t equals to 0, and when r equals to r, then t equals to r square by 2 sigma square. Putting all these values in equation 1, we will get frr equals to integration from 0 to r square by 2 sigma square e raised to power minus t dt. So minus, the integration will result into minus e raised to power minus t from limit from 0 to r square by 2 sigma square. Finally we will get FRR equals to 1 minus e raised to power minus r square by 2 sigma square. Since we know that r is greater than equals to 0 always, therefore the above equation may be multiplied by unit step function UR. Hence Rayleigh CDF has 1 minus e raised to power minus r square by 2 sigma square UR. Thank you guys.